In this tutorial, I'm going to walk through creating a complete scene with RayTK. I'm going to start with downloading the library, and the current version is 0.10. Get this from the GitHub repository and the releases page. There are files in here, but these are development files that are not going to be useful for just creating scenes. So in this first one, we've got this tox file here, so we're going to download that and then drop that into our project. There we go. So the toolkit is loaded now, and when I use the Alt-R shortcut, pops open the palette, and the palette has been redesigned in version 0.10. Gonna start with a generalized polyhedron SDF. Connect that to a RayMarch render, and then add a null at the end of that so we can see the result. So there is our polyhedron. I'm going to set this up so that we can see it a little bit better in the video, so I'm going to split this pane and turn on the display flag on here, and then switch to top viewer, and then in here I'm going to go to display and turn off background tops, so that we've got rendering on one side and network on the other. I'm going to change the resolution for now just to something that's a little bit closer to that shape so we can see it a little better. And go with 1000 by 2000, and we'll change that later, but just for now that's good enough. And so this scene is going to be using this polyhedron and then feeding that through an iterated transform and a couple of other things, and so that we get kind of a sort of fractally shape, and then it's going to be blending that with a kind of a ground plane. So I'm going to start with that iterated transform. And connect that in there. Switch off scale. There is currently a little bit of a bug in iterated transform that causes some rendering errors when you're using scale. So for now, it's recommended to not use scale. I'm working on figuring out what's going on there, but for now, just stick with it without. And I'm gonna add a camera so that the default camera that comes in the renderer is useful for quick stuff, but is not, you can't really customize it. So I'm gonna create a look at camera and connect that to the camera input, which is the first or the second one here. And there is a little bit of a bug in 0.10 that doesn't always recognize when you've connected or disconnected the camera input specifically. So to work around that, if you just go into the network and then pop back out, for whatever reason that causes it to recognize the change. And once you've got it recognizing that, it'll pick up changes to the camera itself, so you don't need to worry about it there. So I'm going to zoom out a little bit on the FOV angle so we can see it a little better. Now that we've got the camera set up, I'm going to experiment a little bit with the settings on the iterated transform. specifically the rotate. So if you changing the rotate settings here, you can see that it is rotating the shape, and then it's also reflecting that across currently across the X, Y, and Z axes, and then repeating that process currently 4 times, which gets some interesting sort of fractally shapes. And since we're not using translate here, I'm just going to switch that off. And I'm going to try different reflect modes, see what happens if I just do on X. So now it's just reflecting across the X-axis when it's applying that rotation. So that's pretty neat. I'm gonna leave that as it is for now. And I'm now going to add a mirror octant after that. Mirror octant, which is a kind of kaleidoscope-like effect. If I switch that, just go straight into the polyhedron for a second just to see what that looks like. So what this does is it reflects space across 2 axes, currently the X and the Y axis. This size controls how much it spaces out the shapes, and then offset is a shift that it applies to the shape before it does the reflection, so it kind of moves it kind of along or into the reflection planes. So I'm going to zoom out a little bit more so we can see that. There. And there's also the rotate axis option, which spins the shape before it applies the mirroring, so that you can get some kind of kaleidoscope style effects there. I'm gonna hook that up to the iterated transform. Reset this offset here. Okay, so right now, basically all this is doing is just making 4 copies of, it's making 8 copies that are cut along the X, Y, and then also along these diagonal planes. So you can see there's kind of mirroring across that axis there. I like that, but I also want another, so that's good for kind of the corners. If I change put the radius down a little bit there, that's good for the kind of corners, but I'd also like another copy of it in the center. So to do that, I'm gonna create a combine operator. Connect that to the iterated transform, and then also to the mirror octant, and then connect that to the render. So now we've got both the mirrored version of it and their original version of it being combined together. And it's important to note that because this is now being used in kind of 2 pathways in the graph, that these parts are now being used twice as often, which can have an impact on performance. So it's generally good to try to avoid having complex stuff that is upstream of something that is using the output multiple times. But here I think it's okay. I'm gonna try changing the blend mode or the combine mode here to smooth union, and then increase the radius there so they're a little closer to each other. And if we change the smooth, the blending radius on the smooth union here, you can see that it starts to blend the shapes together where they get close to each other. So as I mentioned earlier, this is going to be using both these shapes and then also a ground plane. To do that, I'm going to create a plane SDF and another combine operator here. Also set that to smooth union, and then connect that to this first combine and then also to the ground plane there. And I'm going to set the axis on this plane to the Z axis so that it's facing the camera, and then connect that second combine to the render here. So I'm going to zoom the camera out, move the camera back a little bit so we can see a little better. If we drop the radius down, you can see that it's basically just those shapes and the ground plane just kind of sitting on top of each other there. If you increase the blending around it, then you start to get some interesting patterns in the way that it tries to apply the blending, because the shapes that it's blending are, well, one of them has these hard edges and the other is just a flat surface. The blending results in this kind of interesting combination of these kind of hard edges that then smooth out into just a solid plane, which I like a lot. So I'm going to experiment with that a little bit. Increasing that radius up pretty high looks good. And then we're also doing a similar kind of blending between the shapes there. So if you turn it all the way off, then this is there's no blending between them. There's still blending between that shape in the middle and the ground plane, and then also between these side shapes and the ground plane, but they're not blending with each other. But if you increase that back up, and that's where you get this hard edge there. So if you increase that back up a bit so you get some blending, I like where that's going. So I will leave it there for now. I'm now going to work with the materials a little bit. So right now it's just using the default material that's built into the renderer, which again is good for previewing and that sort of thing, and occasionally even I'll just use it for projects. But if you want control over that, you need to override the material. To do that, I'm going to create a basic material, and I would like to have a different material on the shapes and on the ground plane. So instead of connecting this after the combine here, I'm going to connect it before and on this first one, and copy and paste that and drop that in, another one of those in here. When I change the base color on the material that's being used on the ground plane, you can see that it mostly just has effect on the ground plane area. And because of the amount of blending that we're applying there, some of it kind of has an impact on the shape in there, but that's just because it's there's so much blending going on that they're starting to overlap. I'm going to change the And if you change the settings on the first material, you can see that that applies just to those shapes. And in operators that like combine, that are blending multiple different SDFs, most of those will will handle the materials. It will pay attention to which material is on which input, and it will keep things assigned to the right input. And it will, in cases where there's blending between the two, it will interpolate between the two materials in that blend area. And this is currently only really supported for a single level of material blending. So if you were to have a third shape here and then you tried to blend that with the combined thing of these two, you'd end up losing one of the three materials. So for now, just try to keep the material blending down to just two of them. For the material that we're using on the shapes here, I'm gonna go with a desaturated orangey, all sort of a yellowy brown. And for the ground plane, I'm gonna go with more desaturated darker color here. And this basic material has that base color, and it also takes in the lighting that's being applied to it. It also has this sky color, which is sort of a rough approximation of another light source, which you can pick a color and an amount and then a direction, and this is the vector that the light is pointing in. So it looks at each point on the surface and sees how close it is to pointing to the direction of the light, and then applies that level of color, which is similar to how real lighting is applied, but in this case, this doesn't have shadows or anything like that. So it's just a much simpler and kind of cheaper secondary light source. But if you turn that down, and I'll turn it up, and then you can see if you move around that direction, then you can see what effect that has. I'm gonna stick this off to the side a little bit, so like 0.7 and then 1, and drop the level down on that so it's pretty minimal. And this specular amount here is the amount that the main light is applied to the surface color. So just leave that for now on both of these at the default setting, 0.5. And now gonna take a look at the light. So now that we've got the materials set up, I'm gonna add a light. And similar to the camera, the renderer has a default light built into it, but you don't have control over it. So if you want to change the light, you need to provide a different one. And there are two ways to do this. You can either create a Touch Designer standard light and drag that onto this light parameter here. And if you move that around, you can see it's being used there. But removing that, the other option is to create a light operator, so here a point light, and connect that to the light input, which is the third one here. And so the default position on that is just at 0, 0, 0, which is not that useful to us. So I'm gonna bring that out in the Z to, like, say 1.8, and then move it off to the side a little bit and up, and increase the intensity on that. So this is showing a good case of one of the limitations at the moment of the shadows. So certain combinations of lights and types of surfaces will not necessarily play well with the default shadow. And you can either disable shadows, so and that's done in the material. So if I switch that off on the material that's being used in this base plane, it's still applying the shadow to the shapes, but not onto the base plane. And that seems to get rid of that particular problem around there. Another alternative is to provide your own shadow operator. So there are currently 2 of these supported. There is hard shadow and soft shadow. And to use that, you would connect it to this second input on the material. And to make this a little bit easier to see, I'm going to move this light closer to the surface and then further off to the side so that we get a more a little bit sharper of a shadow there. And this hardness parameter will control the amount of the sharpness of the shadow. This soft shadow operator is can behave a little bit strangely sometimes. So particularly with surfaces that are like very flat but slightly curved, some of that can produce some pretty interesting effects, but eventually the goal is to improve that and at least provide control over it. The other option is hard shadow here. Connect that up. And you can adjust the level there, but the hard shadow is a little bit more consistent, but again, you don't get you don't necessarily get the same kind of smoothing of the edges of the shadows. It's a little bit hard to see here because the ground, I'm trying moving the ground plane back a bit further, and then I'm gonna connect up this same shadow to this other material as well, and then switch on shadows there. So you can see here that it has these hard edges, whereas the soft shadow, connect that in, and then can see that it's got kind of a you don't get the same hard edges, but again, it's a little bit less consistently correct. So for now, I'm going to switch back to hard shadow. And then I'm going to bring that ground plane back up a little bit. Actually, for now, I'm just going to switch off shadow entirely on both of those materials. We already get some amount of kind of shadow-like behavior from surfaces that are facing away from the light, so I think that's sufficient for now. And switching off shadow is also a way to improve performance, sometimes by a lot. And that's because to come up with the shadow, it needs to, once a ray hits a surface, it then needs to cast another ray from that surface to the light to see if there's anything blocking it, which means that it has to do a whole bunch more calculations. So if you don't need shadow, then you can switch that off. Now that we've got the materials and the lighting set up, which we will adjust later, but for now I think this is good enough. I'm gonna start working on animating this, and there are a couple of different approaches to doing that. The most straightforward one and kind of standard touch designery one is to animate the values of the parameters here. So you could use chops to have those values change over time. Another option is to use value fields. And this is something that's been in previous versions, but has kind of been more of a focus in the current, in 0.10. I'll start with a rotate operator and insert that between the polyhedron and then the iterated transform. And we're going to use this because if you apply this rotation before the iterated transform, you still end up with a lot of that kind of fractally effect, but it's a little bit simpler to work with and calculate. And it has this, it has support for value fields, which iterated transform doesn't currently. So you'll notice on the rotate that there is this second input, and that input accepts a value field. So there's another class of operator in here called field. And what these do is they provide a way for other operators to calculate some value for a given point in space, and then have that potentially vary for different positions in space. So I'm going to use, just for now, a point distance field. And what this does is it returns the distance when the rotate asks it for a number. It will give it the distance from wherever point the rotate's looking at to the center point that's set in here. And what this is returning this is providing a single value in the field, so it's like a float value as opposed to a vector. And when you give rotate a float field and you're using and you're using the Euler XYZ rotation mode, it will multiply whatever setting you have in here by those numbers. So if this is set to, if this were set to all zeros and you try moving this point around, you're not going to see any effect there. But if you change it, I'm going to go with Z for now. And to make this a little bit easier to understand, I'm going to pop open the inspector here. So I'm going to rotate that around, zoom in a little bit. And I'm going to use the menu up here to switch to that, so I can just edit that in place. It's still a little bit hard to see what that's doing, so I'm going to try a different field. I'm going to rescale the field. So right now this is just providing whatever the distance from that center point to wherever. This rescale field lets you change the range of values there. So if you increase this really high, then pop this open. All right. So you get this, and that's what it's doing here is it's applying a different amount of rotation to each point, and the further that a point is away from that center position, the more rotation that it applies, which gets it this twisting effect. And if you push that really far, then you can get to points where you can get some errors there, but if you leave that at somewhat lower range, that could be interesting effects. But what we're going to use instead of a point distance field here is a time field. And time fields are a little bit different from other ones where they don't really care about what point in space the operator is looking at. They just provide a value based on time. So I create an LFO field here and connect that up. And then increase the amplitude there. And just to make this a little bit easier to see for now, I'm going to switch off both of these. And then drop the blend radius down a little bit. So what this is doing currently is it's using the timeline, and every 4 seconds it has a loop that is 4 seconds long. The reason that you get that jump there is because the timeline here is set to a short time, so when it hits the end there, boom. Because that's not an even multiple of 4 seconds, then it resets. You can also use absolute time, so this is just a continuous value that isn't connected to the timeline at all. And in fact, if you pause it and then because it's paused, it's not updating the render. But if you enable it again, you can see that it is using it considers the time that elapses even when things are paused. And the reason that this is looking like just a constant motion here is because this is using a ramp from 0 to 9 currently, and if you apply that to, set that to 1 or something, you can see that it is rotating like up to that value of 1, and then it resets. To control the shape of that pattern, can use a wave function. Functions are another class of operator that can be used when another operator wants to define how values are shaped in various ways. In general, the function system is not super well developed, but it is the best way to set the shape of an LFO. So right now this is using a sine wave, so you get that sine wave pattern in there. You increase the amplitude of that, that will spin more. So far we've been using a single value field, so it's a float value field, and it's just multiplying whatever the setting is. So if you change this to a different kind of rotation, then it will spin on different axes. Another way to use a field there is to use what's called a vector field. And a vector field is a lot like a float field, but it's got, instead of 1 value, it provides 4. So the easiest way to create one of those is to use one of these float to vector operators. And if we connect that in here, so this is now providing 4 different values, and when rotate gets a field that has those 4 values in it instead of just a single one, then it uses those as the X, Y, and Z rotation, which it adds to this rather than just multiplying. And right now it's using this input for all of the different parts. You switch some of these to 0. And that last one it doesn't actually use, but I'm just gonna set it to 0 anyway. Increase the amplitude here. So you can see that it is using this LFO right now to control just the X rotation. I'm gonna create another LFO. Just copy and paste this, and it's going to use the same wave function there, so they're both sine wave LFOs. And I'm going to change the period on this one to say 8, so something that's an even multiple of that. Connect it up to this vector, and then I'm going to change the Z to use that second input. So you've got one that is using the like a 4-second sine wave to control the X rotation, and then another one that's using an 8-second sine wave to control the Z rotation. Now this is definitely more complicated approach than just using chops or something to animate these parameters. But it does have the benefit of being a lot more efficient, especially if you have a lot of these, and that's because it doesn't have to deal with some overhead that happens when you're feeding parameter changes into the scene. So the parameters are here all the same, and it doesn't need to be it doesn't need to keep continuously passing those values as they change in every frame. And this time system is something that will be more heavily developed in 0.11. So the goal is to have other ways to kind of manipulate time, because all of this is being calculated within the shader. Then we have, and part of that is something that looks at, what time is it currently, and then it uses that to control various things. You can have the answer to that question of what time is it currently be different for different points in space, which has some interesting potential, but is still under development. So for now, just going to be using this as a way to animate those two, the rotation on that. I'm going to switch on both the iterated transform and the combine there. That's got it's got a pretty good pattern on its own. Clean this up a little bit. So to review the scene, we've got this polyhedron, which is kind of the base of all the geometry. That's going into a rotate, which is being controlled with these two LFOs that are spinning it on the X and the Z axes. This one at a 4-second period, and this one at an 8-second period. And that's being fed into an iterated transform, which is giving it some of that kind of fractally effect, which rotates it a bit, reflects it, rotates it a bit, reflects it, so on. And let's change this back to XYZ. There we go. So this is, rotating it and then reflecting it across all three of those axes, and then rotating it, and it's doing that 4 times. Then there is a mirror octant, which is, again, reflecting space across those 2 axes and then also across the diagonals. And then that's being combined with the original using this smooth blend, which lets you blend between the shapes. That is got a material set on it, and then there is a plane, which is the ground plane, which is got its own slightly different material, and both of those are being combined with another smooth union operator. And this also has that radius to control the amount of smoothing there. Both of these materials are using currently have the shadow switched off. Actually, just delete that. Then all of that ends in a Raymarch render, which is using a look at camera, which we can move around, and it will always stay pointed at this look at position. So if you move that, it changes what it's facing. It's also using a point light, which lets us control the position and coloring and intensity of the light. And then it's rendering that out to the final output. I'm going to change the resolution back to, say, 1920 by 1080. And move the camera in a bit. And switch on background tops. Maximize that. Parameters. Clean up. And this is our scene.